Alrighty guys, welcome back. In the last video we have seen how we can establish a man-in-the-middle attack. And this setup, this is really awesome because we not only intercepting HTTPS traffic, we can see every connection the client is making. Freaking awesome, right? It's also being re-established within seconds, which is even more amazing. But for now we are having one problem. The problem we are having is the following. We've got our smartphone over here. And if the smartphone is now connecting to a web page, for example, example.org, then the package will rush through our network. So we can see this in Wireshark, but we are not able to stop, intercept, manipulate, or redirect it. And this is definitely something we want to have. Also for the response of the server. I mean, we see the packages and the website is loading on the smartphone. We can see the whole content regarding to HTTP. Okay, we will later see how to deal with HTTPS. But for now, let's stick to the connection. We can see this connection, but we cannot manipulate it right now. And this is something we definitely want to have, right? At least I would like to have this feature. And therefore, let's tune our setup even more. So how can we establish this right now? Instead of rushing through this whole network, if you're opening a web page, we want to have the following. The package should arrive at our interface. Then we also see it in Wireshark. Absolutely perfect. But afterwards, we don't want that this package automatically passes this interface and goes out into the internet. The kind of magic we are establishing right now is a local proxy. So it looks like this one. Freaking awesome, right? So we are having a local service listening on a certain port. And what we are doing right now is the following. Instead of passing this package through this whole interface, we redirect it. We redirect it to our local service. Instead of going through this, it gets redirected to our proxy. Here it stops and we can analyze, manipulate, and also forward it afterwards to the internet. By having this, we can now inspect and manipulate packages, it's really awesome. This also automatically happens for response packages. So if the response package arrives, it doesn't automatically get routed through our network interface. Also, the response packages will stop at this point. We can inspect, manipulate, and forward them to the original smartphone. So this gives us a lot of possibilities. I mean, we could also try injecting JavaScript code or other stuff into these packages, which might have some side effect on the smartphone itself. Regarding to pictures or text, I mean, it can be super funny to manipulate or interact with this one. But we can also use this to exploit certain features in this mobile application over there. So now's the question, how can we do this? How can we stop these packages and reroute them through our interface? The answer for this one, to establish this kind of magic in the background, requires only two steps. The first one is we need to enable IP forwarding in our kernel. This can be done with the following command. Enabling this feature simply means if we have a package and multiple interfaces, the package gets automatically rerouted through them. For example, our package arrives at our interface 1, which is 10.42.0.1, our gateway of our USB to Ethernet adapter. But the destination is regarding to the outside world. Therefore, it needs to be rerouted through our NAT adapter of this virtual machine, our interface 2. This is our internet access. And by enabling this feature, this package can now be rerouted through this interface. So this is a core feature that needs to be enabled in our Ubuntu VM, but it doesn't perform the rerouting for our package to our local proxy listener. And this type of magic can be done with IP tables. IP tables are freaking awesome. They are some kind of package filters, but it doesn't mean that we are just dropping packages. We can also define a certain rule set to reroute packages based on some certain conditions. So we can do a lot of stuff with IP tables. So you should definitely check out IP tables if you have some spare time. Alrighty? Okay. For now, we only need to deal with one command. This command over here. This command performs the magic for port 80. So it looks absolutely ridiculous, but it makes sense. I mean, IP tables always make sense, but it's hard to read if you're doing this for the first time. Therefore, let's go through this together right now. Alright, so here we are back on the graphic tablet, and this is our setup we already got. This is our basic man-in-the-middle setup. In this video right now we have added the burp suite, a proxy listener on 10.42.0.1 port 8080. So what does it change in this setup over here? Well, first of all, not much, but nevertheless, let's insert it. So here we have now our proxy listener, the burp speed on 10.42.0.1 port 8080. And this is our burp suite proxy. Alright, this simply means on this network interface over here, we have now a proxy listener on port 8080. But we do not reroute any traffic right now to this proxy. We just have it running on this port over here. Okay, so let's get into this huge IP table rule and figure out what it does. We do this step by step. So we split it up into single pieces and then we will apply this on our drawing underneath to figure out what it changes in the package. Alrighty? Let's go. Okay, so our command starts with IP tables -t nut. So -t means we want to apply our IP table rule for the table nut. We also got two different tables. We've got filtering and we've also got mangle, but we can ignore them for now. NAT means network address translation. And in the context of IP table rules, it simply means change or give us the possibility to change IP addresses in a package. So if we have here our package, this one over here, and this is our HTTP package for example.org. Then we want to change the IP addresses in this package over here. So we want to be able to swap them. Changing the IP addresses of a package gives us the possibility to reroute this package. So in our case, what this means is the following. Instead of going directly through this from here to here, we want to reroute this package from here to the burp suite. And yeah, we have to define a lot of more parameters that the IP table rule exactly knows what to do. But this is our generally table, and yeah, this is where we add our entry right now. Okay, so NAT simply means network address translation, and this is the table where we want to add a new rule right now. Next, we've got this capital -A. And this simply means appending a new rule. We also got capital -D, which means deleting an existing rule based on the configuration parameters afterwards. In our case, we want to append a new rule, therefore, yeah, we use the -A command. And now we have some chain. A chain simply means some kind of action which we want to perform. In this case, we have an -A and we want to add a new pre-routing. We've got pre-routing, we've got post-routing, and we've got other stuff. But pre-routing and post-routing, these are the most two important ones. Pre-routing simply means if a package arrives at an interface, no matter what interface. So it could be this interface over here, or also this interface over here. Then we are now defining a new rule where we want to route this package. So this example.org now arrives at our interface. This is, for example, the USB to Ethernet adapter over here. USB to Ethernet. Let's call it, let's write it in this way. If it arrives at this interface, we want to change the routing of this package right now. And this is exactly what we want to have. Because instead of going this way, we want to change the routing to go this way. Upwards to our burp suite. And this is the new routing we want to change. Alrighty, so the next parameters are regarding to the package itself. So we need to be very precise on what type of package we want to re-forward. Otherwise, we will forward all of them from a specific type, for example, all TCP packages, and this will be a completely mess. We only want to forward HTTP packages. So let's also write this down over here. HTTP packages. All right. So these are the only type of packages we want to forward. Alrighty? Okay. Therefore, the next parameters regarding to the protocol. So -P. And then we've got different protocols. We've got TCP, we've got UDP, we've got ICMP, and a lot of more. HTTP requests are regarding to TCP. So therefore, we only want to forward packages which has the protocol or which are from the protocol type TCP. Alright, but by writing it in this way, now every TCP package will be affected by this rule. This means if the smartphone is making an SSH connection, an Telnet connection, an FTP connection, whatever connection the smartphone is making regarding to the TCP protocol, these packages will be now forwarded. Therefore, we need to be a little bit more precise on what type of package. Now we have the protocol TCP. That's good. And now we need to define only HTTP packages. And we can do this by applying a destination port. So this is the next parameter. --the port 80. So what does this mean? Our package, example.org, this one over here, this has a destination address, which is example.org. I mean, that's the DNS name, but this DNS name gets translated into an IP address. Beside this IP address, this package also has a destination port. And if we are performing an HTTP request, the destination port is most of the time port 80. Otherwise, we have to include this port in our URL. So for example, like this one over here. Let's clean this up a little bit. So if you want to make an HTTP request regarding to another port, we have to append this port at the end. For example, let's say the HTTP server is not running on port 80, it's running on port 8010. Then we need to append colon 8010. And now the destination port is 8010 instead of 80. But we have to do this manually. So if we do an HTTP request, the destination port will be as default port 80. Alright, therefore by applying this rule over here, destination port 80, we only forward packages which are regarding to HTTP requests. So exactly what we want to have here. In case if the smartphone is making a request to a different port, so not port 80, for example, port 1020. I mean, it can be every port. It's just the default behavior for HTTP requests that they run on port 80. But let's say the smartphone is making a request to this one over here, and it's also an HTTP request. Then we need to also add this port to our destination port, and we can do this by simply copy pasting this rule. So we copy paste every command in here, and instead of destination port 80, we change this to 1020. Then we also forward all these requests regarding to this destination port to our proxy listener later on. We can observe this with Wireshark. So if you run Wireshark, then you sniff the whole traffic the smartphone is generating regarding to this setup over here. So you can see every request regarding to, at least the IP and the port. I mean, if these packages are being encrypted regarding to SSL, so HTTPS requests, these are being encrypted, but the IP and port, these are known to you. These will be not encrypted in the package. And by observing the Wireshark traffic, we can simply summarize all this information, and then we can apply all our IP table rules that we forward all these, strange, obscured, whatever ports you want to call them, to our proxy listener later on. Alright? So now we've got the destination port 80, and the last thing we need to do is the package now arrives at this interface. Let's draw it over here. So this one arrives now at this interface, which is this one, for example, or also this interface. And now if it's an HTTP package from type TCP, destination port 80, we want to forward it instead of going this way. We want to forward it going this way into our Burp Suite proxy, and then from there also backwards into our second NAT interface and into the internet over here. This is the route we want to take. Maybe let's do it a little bit more clearly. So, alrighty, and this is exactly what the last parameters in our IP table rules here does. So we've got the last parameters, we've got -j, DNet. DNet simply stands for Destination Network Address Translation, which simply means switch out the destination address of this package. And this is exactly what we want to have if the package arrives at the network interface. So for example, this one over here. Let's say we've got a package regarding to the destination, example.org, on TCP port 80. Now, instead of going this way over here, we want to change the destination address to 1042.0.1. So it should go the way upwards. This one over here. And this is the last parameter we have to provide. We want to change the destination address to destination 1042.0.1, and now we also need to provide the port, because this is also included in the destination of this package over here. And the port is 8080. And by doing this, we have achieved everything we wanted over here. So now every HTTP package that arrives at any interface, no matter if it's this or this interface, they will be now rerouted, or the destination address will be changed to the address of our proxy listener over here, which means they will be rerouted to our proxy here, which is listening on 1042.0.1 port 8080. Alright, at this point we are done with our IP table rules over here. So we have figured out exactly what this one does. Maybe let's do one last recap of everything right now. Alrighty, let's make this a little bit more messy than it already is. So let's pick a good color. Let's see. I guess this one is good to notice. Okay. So now let's recap this. If we're making an HTTP request from our smartphone regarding to this address, for example, the package will be now routed through the router into the USB to Ethernet adapter. And here we have now our network interface and our IP table rule established. Every package that arrives, we have now a pre-routing rule. This one over here. So this means if this package is from type TCP, yes, it is. It is TCP. And if this package has the destination port 80, it's also true. Then change the destination address from whatever it is in this package, this one over here, to this destination address. So to this one over here, which means the package arrives at this interface and it will be now forwarded to our proxy listener. I mean, is it still possible to draw here? Yes, okay. So we've got this huge redirection to this proxy listener. But now we've got one problem. This proxy listener here is not automatically forwarding it back to this one over here. But this is where the burp suite comes super handy. We do not have to change anything in the IP table rule over here. This one, it's completely ready. We can do this within the burp suite. The burp suite has a mode which is called invisible. And this mode acts like the burp suite, this proxy listener, is not here. Which means the package gets rerouted to the burp suite, yes, exactly what we want to have, but afterwards the burp suite is rerouting this package automatically to the destination which has been provided before. So that's the feature of having an invisible proxy like the burp suite. We therefore do not have to configure, change or modify anything right now. The only thing we need to do is we need to set the burp to act as an invisible proxy, and then we also got the route backwards. Alrighty, that's all for now. In the next video we will set up this proxy listener, which is the burp suite. It's a super amazing proxy if you want to deal with web services. And there we will also take once again a look into this IP table rule over here. Alrighty? Okay, so I'm looking forward to see you in the next video.